Hi everyone, today we're going to solve a question regarding the pressures underneath the liquid itself, as well as pressure that exerted on a certain object. So what exactly is pressure? So as a prior knowledge, pressure exerted on any object is force per unit area. To remember this in a simple way, usually I will tell my students in this way that if someone is experiencing a pressure, it's as if it experienced a force being pushed by some huge person on his area of the body. And that's how you can remember pressure is actually force per unit area. And if this pressure is pressure of a liquid, then we can use the formulas of P equals to rho GH in order to solve that, whereby rho is the density of the liquid itself, G is the gravitational acceleration, H is the depth on where the object is beneath the water. So as we can see from this example, figure shows a diver 50 meters below the surface of the water. So definitely we need to apply the formulas of P equals to rho GH. So let's make some applications. In here, we know that P equals to rho GH, in which rho is having a value of 1000 kg per meter cube. G is having a value of 10 meters per second square. And H, the depth where the diver is 50 meters beneath the water. Solving this one will give you 5 times 10 to the power of 5. And do not forget that this is physics. That's why we must add a unit of Pascal for pressure. So, ta-da! There we have it. 5 times 10 to the power of 5 Pascal for the pressure exerted on the divers by the water. So, the second part of the questions here says that the windows in the diver's helmet is 150 millimeter wide and 70 millimeters from top to the bottom. So, let's see where the helmet of the diver is. Basically, is at here. So the helmet, if according to the dimension given, is 150 millimeter wide and 70 millimeter from top to the bottom. 150 millimeter wide here, and we need to change it to meter instead, because when we are applying pressure equals to force over area, the area here must be in the unit of meter square. So we must change this millimeter to their respective units in meter. So if we make respective changes, 150 millimeters will be equivalent to 0.15 meter. 70 millimeter will be 0.07 meter. Then, if we are applying the formulas inside the second part of the questions, where they request us to calculate what is the force that the water exerts on this window. So, according to the original formula, pressure equals to force per unit area. Rearranging the formula itself, we have force equals to pressure times with the area. So what's the pressure exerted on the diver just now? Pressure exerted will be 5 times 10 to the power of 5, as what we can see here. Whereas the area, we need to calculate what is the area of this cubed shape. So pressure on the divers will be 5 times 10 to the power of 5 Pascal, multiplying with area, which is 0.15 meter, times with 0.07 meter. That is the area of the cube, which is the window being shown by the helmets of the diver. And hence, solving this one will give us 5,250. But again, this is physics, so we must have a unit for force, and unit for force is Newton. And there we have it, 5,250 Newton. And that's how we solved the forces as well as the pressure involving any object underneath a liquid itself. And that's all for today. Hope you benefit from these examples and see you again next time.